Welcome everybody. This is an introduction to the semantic web. This seminar is being recorded to be offered to the students and faculty of the Art Institute of Pittsburgh, specifically the Web Design and Interactive Media department as part of the Brown Bag Seminar Series. This seminar, of course, is about the semantic web and is made to introduce some of the ideas and a little bit of the practice and just overall the concepts that are defining where the internet is going as far as the semantic web.
The internet is very much alive and kicking. The first generation of internet sites primarily gave information. But with the rise of sites like Facebook and Amazon, the web has become increasingly interactive. On this Web 2.0, it's mostly the user who produces the content. Without contributors, there would be no Facebook, and without people who post information on Wikipedia and their clips on YouTube, there would be no interaction on these sites. Meanwhile, most people have become familiar with Web 2.0. Blogging, tagging, social networking, and social bookmarking have paved the way to a next step in the development of the web. The step to the intelligent and omnipresent Web 3.0. Web 3.0 is not totally different from the web we know now. It is in many respects a continuation of existing techniques. Think of the so-called recommender systems that make a personal approach by a website possible. Amazon has cleverly used this system for a long time now by offering their clients products that other people with the same interest bought before them. And on Last.fm, you can listen online to music that caters to your personal wishes. By using smart systems, these sites are in a continuous learning process and they anticipate what their users like or dislike. Important for sites like Last.fm or Amazon is that a song or a book gets extra information added by the user. No sudden change of the internet, it changes gradually. What does change quickly is the look and feel of the web. Simply speaking, the internet is a web full of appliances that communicate with each other by exchanging information. As more and more everyday appliances are connected to the internet, think of telephones, washing machines, and cars, the web is more present, but it will become less and less visible. No big separate computer, but invisibly present in everyday appliances. When, moreover, all these appliances start communicating with each other through the internet, this may lead to useful additional services measured to meet our individual needs. For the time being, we are not yet dealing with an all-knowing, omniscient computer which comes close to or even surpasses human intelligence. Writing computer programs which, in a human manner, convert data into useful information, also known as the semantic web, appears quite difficult. But the web undoubtedly evolves into an environment which is intelligent and which will meet our wishes more often, more easily, and automatically. New services develop because data from various sources can be linked more easily. Moreover, with the good and often wireless infrastructure, these new internet services are always and everywhere available. Your online agenda becomes a personal assistant which, all by itself, for instance on the basis of your profile on LinkedIn, Facebook or other information, will check your possibilities for new appointments and even take traveling times into account. Your destination and itinerary too will have been sorted out by links between restaurant sites, GPS information and local weather services. EPN, the Dutch think tank on the impact of information technology, approaches Web 3.0 from various points of view and draws attention to its implications for society.
So what are we talking about here? We're talking about some versions of the web. We hear this term Web 3.0 and the semantic web and the web of data. And really, Web 3.0 is more than just what we're referring to when we talk about the semantic web. And so we're talking today in this seminar specifically about the semantic web, and we'll get into what that is in a minute. But if we look back, we can kind of see what the video was talking about as far as Web 1.0. These are sort of general timelines about when these characteristics and these methods in which the internet was being used were in effect. And so we have Web 1.0 from early days, as we call them, from when Netscape Navigator first came into homes in the US and around the world, which was really the first popular web browser, and early provider services like AOL and Prodigy in the early to mid 90s and through the late 90s, when everything was very code heavy. We're talking about static HTML pages, and for webmasters and for web developers and web designers like ourselves, we're talking about a lot of bottlenecks. So there are far fewer of us, but with the growing need of content to be put on the web and no content management tools, anything like that really in place yet, we are seeing a lot of bottlenecks. And then we moved on to Web 2.0, which you didn't really hear about Web 1.0. You hear about Web 2.0 to sort of differentiate it from this static code-heavy early days of the internet. And so Web 2.0 is when we started sort of to first hear about these versions. And we're talking roughly about the first decade or a little bit less of the new millennium. 2000 to 2008 approximately is when we started seeing this huge rise in user-generated content and social media and tagging technology, and things started to really make a shift from being the static, code-heavy, redundant sort of programming to dynamic, data-driven websites. And so these 3 bullet points here really work together of course, we probably should have another bullet in here about internet speeds. And so, with that speed that was opening up, especially to places of work and universities and even to people's homes, we saw an increase in the use of audio and especially video, right? So if you put that, speed enable user-generated content really would be a 4th point here. And so all of these things work together to really define what Web 2.0 was, or still is. We're still very much there, but with everything technologically based, it continues to improve, and we're started to move into this Web 3.0 area, and we're talking a lot about the semantic web and this web of data. So that the key characteristic here being that not only are all of these web pages and all of this web content going to be usable by humans looking at a screen, but that it will also be usable, indexed, searchable, and have meaning to computers as well, right?
This is a quick introduction to the semantic web. Over the next couple of minutes, I'll outline one of the toughest problems the web is facing today. I'll also explain what's being done about it and how it's going to affect you. You don't need to be a web developer or a blogger to understand any of the concepts in this short intro. If you can open a web browser, then you can understand the semantic web. So before going any further, it's important to know what the word semantics actually means. Semantics is related to syntax. In most languages, syntax is how you say something, whereas semantics is the meaning behind what you said. Let's take the phrase, "I love technology," as an example. The syntax is all of the letters, words, and punctuation in the sentence. The semantics is what the sentence actually means. In this case, it means that you enjoy learning about and using new technology. Now, if we were to change the sentence using a different symbol for the word love, we have changed the syntax of the sentence. However, note that the semantics of the sentence is still the same. When you write "I heart technology," it still means that you enjoy learning about and using new technology. When we talk about syntax and semantics, what we are really talking about is communication. When you want to communicate with somebody else, you use your voice to do so. The internet created a standard way for computers to communicate with one another. In other words, it gave a voice to computers so that they may talk to each other and exchange information. However, much like a parrot can mimic human sounds without understanding them, computers merely mimic human information to one another. So while the internet enables computers to talk to one another, it was not designed to teach them what the information actually means. When the web came along, it created a very quick and easy way for us to retrieve and view information. You can think of the web as a huge document storage and retrieval system. When you put a website address into your browser, it sends a request to the website. The request basically states that you would like the document located at the address that you gave it. The website retrieves the document and sends it back to your web browser. This document is written in a language called HTML. The HTML language defines a syntax that computers can understand. It tells a computer how to display the document to you. So the two really neat things that the web did is create a way to get any document on the internet, and it also created a syntax called HTML that is used to display the document for you. So what's the big deal? We have the internet that lets us talk to each other. We have the web that lets us store and retrieve any document on the internet. And we have search engines which can find just about any website that we'd want. The web is already pretty good, so how are we going to make it any better? The answer lies in semantics. Remember, computers today just blindly retrieve and show us information. That's the problem. Computers don't understand the meaning behind the web pages that they're showing us. While they may understand the syntax, the semantics are lost on them. Now, if we could get computers to recognize what's in a web page, they could learn what we're interested in. If they know that, then they can help us get what we want. They would change from passively helping us to actively helping us. This is really what the semantic web is all about. It helps computers understand the meaning behind a web page. The web of today is about documents, whereas the semantic web is about things. When I say things, I mean anything. People, places, events, music, movies, organizations, and just about any concept that you can think of. The semantic web is not only about pointing these things out to a computer, but also about letting computers know how these things are related to each other. There are several promising technologies that are in use today that can embed semantics in HTML documents. Two of the more popular ways are called microformats and RDFA. So the semantic web stuff isn't about something that is going to happen in the future, it's about something that is happening today. Things get really exciting when we start to explore the possibilities of the semantic web. Once your computer can understand what a person, a place, and an event is, it can start helping you interact with those things. For example, if a birthday party is marked up as an event with a date and a place, you can tell your computer to save the date in your calendar. Another example is in the world of music blogs. Music blogs usually list songs and album reviews on their front page. If the blog marked up the songs and the artists using semantic technology, you could tell your browser to find all of the songs on the page, or search the internet for other albums by the same artist. Search engines would also become a great deal more accurate than they are today. When you search, you could say that you're searching for a person, a place, or a particular song. A search engine could then refer you to a website with far more accuracy because it wouldn't have to just depend on keywords in web pages anymore. It could also depend on the semantics in that web page. So the semantic web holds a great deal of promise in making our lives easier by helping computers help us get what we want. If you'd like to find out more about the semantic web, there are a couple of websites that are good starting points. If you'd like to know what all of this looks like in a web browser, check out the Operator plugin for the Firefox web browser. There is also a group of people on the web called the Microformats community that are working on spreading the idea of the semantic web. Last but not least, the semantic web is also a major focus of the World Wide Web Consortium. They are the people that are working on HTML and RDFA and many of the other technologies that power the semantic web today and into the future. This entire video and all of the source material used to make it is available under a Creative Commons Attribution Share-alike license. That means that you can remix and distribute copies of this video over the web or via any peer-to-peer network. I hope that you've learned a bit more about web semantics and why it's an important part of the web's future. If you found this introduction helpful, please share it with your friends.
Okay, so what we heard a little bit about there were some of these possible outlets and some of the initiatives behind moving towards a semantic web. And one of the organizations, perhaps one of the most important organizations in the internet world that was mentioned was the World Wide Web Consortium, or also known as the W3C. And the W3C is very much working toward a solution and working with other groups to get a web standards set of technologies in place that we can all use to start to use the semantic web. And really, so what we're talking about is code. I mean, code is the solution. Code is what makes up the internet, and code is what's going to move us into the next phase when talking about the semantic web and talking about this web of data and marking our pages up, for starters, so that we can express not only the content of the page, but the meaning of that content. And so again, this is about the W3C, the World Wide Web Consortium. It's an international community where member organizations, full-time staff, and the public work together to develop web standards. At its center, its director is Tim Berners-Lee and CEO Jeffrey Jaffe. And we're going to hear a little bit from Tim Berners-Lee about his vision of the semantic web.
From the early days when very few people knew about the web to 3 years later when a lot of people knew about the web, where in that steady exponential growth would anybody say that the web actually happened? There's nowhere. It was an explosion. The explosion is still happening. The semantic web is in the same phase. That if you talk to certain groups of people, they're very excited, completely won over. They're all working using semantic web technology. Other areas, they've heard about it, they've got it on their agenda, but they haven't really had time to go and do it. But on the other hand, you can see that it's got this exponential, that it's locked into this exponential growth pattern. The web, in the first place, was something which solved a particular frustration I had. It scratched an itch that I knew that we could make life a whole lot easier here. The web of data, semantic web, same thing. That frustration that I can't pull that data and pull other data and then connect them and see, oh, when did these publications chronologically fit in with these events? Or where are all my friends compared to all the places I like to drink coffee? Where's the nearest coffee place to a friend that I want to take out to lunch? That's taking information which is out there in a form that can be reused and looked at from a different point of view, combined, queried, sliced and diced, all the things that we do. For example, when we download bank statements into a piece of software which allows us to deal with our finances, we summarize them, we graph them, we see how we do from year to year, we pull out our taxes from them, we do all kinds of things, lots of different views, and we have software which is very specifically written to allow us to do lots of the sorts of things we expect to do with financial data. So now the challenge of putting data on the web in general is that this data is going to be about all kinds of things. So I'm going to want to pull out my financial data and then look at it in the calendar view so that I can see what I was doing when I wrote that check. And then maybe I'll need to figure out to do that, I'll need to pull in some photographs, and having pulled in some photographs, I'll be able to go from the photograph to who is in the photograph through my address book, maybe through the organizational structure of their company or the project they're working on, from one domain into another. And then it's projection of that onto, wow, if this need, what about all these other people who deal with a lot more data, who have much more serious questions to ask on Monday morning? In the life sciences, there's a lot of excitement about using semantic web data. Now, I don't want the next serious emergency to happen until the doctors and the emergency technicians and the rescue crews have got the ability to look instantly at all the data involved, even the data which was not part of the study of diseases. It was a study of air traffic. But I want them to be able to, when they study this disease, to go and look at air travel patterns. I want them to go and look at nutrition patterns. I want them to be able to pull in whatever data they need in order to be able to stop the virus before it's too late. The data web, like the document web, involves standards. Document web as HTML, the cascading style sheets, and so on. All these things are enabled by open, royalty-free standards. Same on the data web. Whereas you represent a document in HTML, you represent data in RDF. RDF is to data as HTML is to documents. That's been defined for several years now. And for some companies that are using semantic web technology internally, they're getting the aha, oh, we can move so much faster. This is very flexible technology. If we had been using conventional database technology, we wouldn't be able to change our business model so quickly. We wouldn't be able to change the sort of data that we're carrying about our products and customers so quickly. For scientists, the aha moment will be when they've read about a paper that they were interested in. They were curious about exactly how the person got to that result, and then they found a link from the paper to the data, and then they found they could just reproduce the processing of the results immediately. I think that's a step which a lot of funding agencies are pushing towards. I know certainly in the US, pushing to say if we're funding you, you have to put your data out there. You should put it out there in a standard format because we paid you to make the data, and you may have published a paper which were based on some results that you noticed. Somebody else may want to do very much of a transverse cut through your data and everybody else's data. We need to be able to get the reuse of the data which we've funded. So I think that's going to be essential for things like being able to respond to disasters effectively, being able to respond to new diseases that hit the planet, and the big challenges like Alzheimer's, AIDS, and cancer, which involve such a lot of information from so many fields being correlated, and the person who has the brainwave who makes the next step forward being able to get hold of the data that he or she needs to be able to make that step. What we're looking for from the web of data is, in a way, what we've found from the web of documents is a sea change. When we started publishing documents on the web, we were publishing documents on the web, so you could go and read some documents. But because you could do it with a click, because the data hypertext link could go to absolutely any document on the web, independent of who that person works for, or where they live, and what language they speak, because that hypertext link is so powerful, there was a sea change in how businesses worked. There was a sea change in how people ran their lives, how they booked flights, of how they ran their families. There were these sea changes in how people keep in touch with each other, and social systems change, and things which just could not be done become possible. With data, the sea change may be even greater, because not only are we allowing people to be able to access stuff more effectively from across the globe, be able to get at stuff which they haven't been able to get at before, but because this is data which can be manipulated, we can put machine power into filtering it down, and then allowing them to join that to other summary data to maximize the human's ability to see the correlations or the trends. It may be that the sea change will be greater. It may be that we'll find that with this sea of data, we will just be able to solve some problems that we haven't been able to solve before. We'll look back and we'll realize that it would have just needed a million clerks plugging away at the web reading, or reading science papers, for example, to have ever stand a chance of being able to figure out to pull in that correlation, which was the clue to making that very serious step forward. So I suppose I've got huge hopes for the long term, and I think that a lot of the people who are driven by the semantic web, in the medium term, yes, we're looking to see enterprise move more efficiently, but also in the back of our minds, there's a very, very exciting long term.
Okay, so what we keep hearing over and over again is this idea that we're moving from a web of documents to a web of data. And one of the examples that Tim Berners-Lee points out is that, maybe at some point in the future we'll realize that, say, the cure for cancer was already in our grasp. We just didn't have the millions and millions of staff members required to go through every paper ever published about anything relevant to this disease and this condition that we have called cancer, and that when we give machines the ability to find the meaning, not only just which words and which images or which files are images across all of these conventional relational databases, but we allow all of this material to have meaning that computers can understand, and then we set loose computers to start pulling this information, this data that has meaning, that's all relevant, and it brings it all in front of a handful of scientists that we do have that can manageably go through all this information and look at all these relationships that are brought to our attention by the computers. And the computers are able to bring all this information together because the web is now a web of data that has meaning that the computers can understand. And so it's kind of like, we can all relate to someone looking for, I don't know, a green bicycle for sale before you could just Google green bicycles for sale on the internet, right? So you can think of all the steps you might have to go through to find just the right green bicycle for yourself, and what you would have to have done before you could do an easy internet search. And you think of how much easier it would be to do that search now. So what we're talking about with the semantic web is this way of marking up the pages and allowing computers basically to do the work. And so microformats, so now we have a couple slides here of just some of the technologies that are in place now. Microformats is one of them, which is there's simple ways to add information to a web page using mostly the class attribute, although you can use some of the other attributes as well. If you are familiar with CSS, you know exactly what we're talking about here. If you're not familiar with CSS, that's okay. We can get you started in that as well. And the class names are semantically rich and describe the data that they encapsulate. So we'll look at some examples here in a moment, not of microformats, but if you want to look at microformats, a great place to start is microformats.org, and they're always easy beginner ways to get started. But microformats is one to remember. RDF, or Resource Description Framework, this is what Tim Berners-Lee was talking about, is to the semantic web, or to this web of data as HTML is to a web of documents. And so RDF is the standard format for marking up your data, and we will look at an example of some of this in a minute. But you can also take note of rdfa.info, or just go to the w3c.org and get all the information you could possibly need on getting started with RDF and RDFA. You've also heard mention of the web ontology language, which is also known as OWL. It's designed for use by applications that need to process the content of information instead of just presenting information to humans. OWL facilitates greater machine interpretability of web content than that is supported by XML, RDF, and RDF schema. It provides an additional vocabulary. So this sort of is, you'll hear about these expressive languages, OWLite, OWLDL, and OWLFOOL. These are all ways of adding additional functionality, to describing and giving meaning to your data. The Dublin Core Metadata Initiative, or DCMI, is an open organization engaged in the development of interoperable metadata standards that support a broad range of purposes and business models. DCMI's activities include work on architecture and modeling, discussions and collaborative work in DCMI communities. They have a lot. It's a group. It's a loose-knit group that works very hard together. So it is obviously comparable to an open source community. And this is a really great place to get started and to find out how you can get more involved in the community, and this is also a great way of learning about how the semantic web is being used, right? And a lot more initiatives than I could list here about the semantic web in practice, right? And so they have task groups and conferences and workshops. If you just go to dublincore.org, you can start to learn all about DCMI. They have a lot more going on than you can probably keep up with. I know that's what I found out, but it is a great resource. And so the way that this is forming is that there's this model, there's this strategy, and so we have this sort of stack of technologies that are in place to help depending on what it is that you want to do with your data. So again, this is some more on the semantic web from the W3C. I don't have the link here, but if you just go to W3C and you can find this under the semantic header. But really, so this is kind of a key explanatory breakdown of these different stacks and what the purpose of each one is, and then what the technology is, or the programming language is that's being used to make these things happen. So for example, if you look the first one here, linked data, and we're talking about the semantic web as a web of data, of dates and titles and part numbers and chemical properties and any other kinds of data that you can think about. Well, RDF, which we heard Tim Berners-Lee talking about as the standard for the semantic web, provides the foundation for publishing and linking your data. And then it talks about how various technologies allowed you to embed data in documents or expose what you have in SQL databases or make it available as RDF files. So now we're talking about the most simple way of creating this semantic data, and we'll look at an example of RDF in a second here, and you can see how you can start very simply, but just think about how this is linked data, right? So this is information that you want to put up there on the web, and you want to give it a semantic markup so that it can be part of the semantic web, so that computers who are told how to understand it can understand it, as opposed to just the people looking at it, right? Or as opposed to just a Google search spider crawling that page and saying, oh, here's a little bit of metadata, and here's a person's name, and here's a phone number that is on this page, and on and on. So we're giving this data meaning, right? and then we're talking about vocabularies, and here we're talking about, so the way these are all broken down is that we're talking about, what we want to be doing, the function that we need, and that is, for example, here the linked data, and then in red here I've listed the technologies. So we're talking about RDFA and GRDDL for linking data, for giving semantic meaning to data we're putting on the web. When we're talking about vocabularies, we're talking about the web ontology language, SKOS, and that's what you want to use here when it's, for example, to be important or valuable to organize your data, right? So now we're not just putting it up there, but we're gonna give semantic ways of organizing the data. So there's when you want to look towards the web ontology language and SKOS, right? So here, now, we may have the need to run queries, right? Query languages go hand in hand with databases, obviously. If the semantic web is viewed as a global database or a web of data, then it is easy to understand why you might need to query that data, right? So if everybody starts putting data up there, we want to find ways of querying that, intelligent ways of extracting the data that we need. And so there you want to look to the Sparkle language, right? Now, same thing with inference. Near the top of the semantic web stack, one finds inference, reasoning over data through rules. The W3C, again, is working on rules primarily through RIF, which is a language, and OWL, which is, of course, our web ontology language. Is focused on translating between rule language and exchanging rules among different systems, right? So not only are we talking about giving meaning, but we're having meaning behind rules and being able to exchange rules among different systems. And if you think about the silo metaphor, right, and we hear this more and more, where you might be talking about organization A is a big, progressive and productive organization, but they have several of these different internal divisions that we might call Division 1, Division 2, and Division 3, and they're all very important in what they do, but they don't communicate with each other very well, right? Even though they're doing a lot of the same things. And over time, we have these divisions, or the three of these divisions, all coming up with their own methods and processes and reasons for doing things, for being productive, and how they're being productive. And so over time, we have these different systems that develop. And, Division 1 may have a system that doesn't necessarily work too well with Division 2. And so Division 1 can't just email all their stuff over to Division 2 and say, here you go, because Division 2 has a whole different structure in place that doesn't allow them to really understand, this information that came from Division 1. So we have this, not only do we have this need for an exchange of data, but to make that data have meaning that the computers can understand. And then, you can also exchange these rules that allow you to work with the data, so that Division 2 can then, write a program or, update their system in a way that can understand, the data that's coming from this Division 1. Right? So it's all about this exchange of data, exchange of rules, and being able to pass this information around. And then there are a lot of different, as we've mentioned already, these collaborative initiatives and vertical applications headed up by the W3C, and they're working. You heard Tim BernersLee talking about these examples in healthcare and the life sciences. All the way, across all industries, because everything is based on data. Everything is based on information. Everything is data. So if you can, get someone who's dealing with a natural disaster, all the information about, how sick the sickness has, or a sickness has affected an area, to the weather data, to, anything, the civic infrastructure, anything that may have some impact on that natural disaster can be helpful. And so if you have this web of data that allows for those people to do this quick search and bring all this information up and sort of sift through it, then you can obviously see the long-term benefits. All right, and so now we know a lot about it, and we know a little bit about how it came to be, and the benefits. But how does it work? And so how do we start marking up our pages to be part of the semantic web? Well, I have a couple of examples here, and I will have these up, and these will stay where they are. So if you're viewing this seminar tomorrow or a month from now, feel free to visit these URLs, and this information will stay in place. And so the first one here goes to this file, and this is just a page on my site that we're talking about some examples and learning the semantic web. And the field is so expansive that I thought to start with some basic introduction to the standard RDF would be a good way to go. And so in this example, we have here what I've called a person identifier. So if you think back to what the RDF is, it's a way of marking up your data and in a semantic way, right, to give it meaning that computers can understand. And so this looks at some fairly simple tags, really, that we include in the code. And if you're familiar with HTML and CSS or XML or anything along those lines, any other languages along those lines, this will seem pretty simple for you to sort of get the main ideas. And with a lot of things, we're talking about code and syntax of that code. So if you visit this person identifiers link here, we are looking, I was going to try to bring it all up at once. Let me close these real quick, then you can see it open. So we're talking about the person identifiers, right? And so this is just a really basic, this is called the friend of the friend, the FOAF initiative. And so this basically is just kind of a person identifier that allows me to input my contact information into a file and to mark it up semantically, and even to add people that I know and things like that to sort of start this chain of semantically marked up data. And so also here, if we look, this is much more interesting, the code view here, right? And so you see it's a series of tags in an HTML page, and we have our header tags and our body tags here, and then we have, for example, in this div, and then we have, like I said, this is the friend of a friend format. So it's this FOAF schema, and we see here that we have, we're marking up that this type is a person profile in the FOAF format, right? And so if you look down, we have a span inside that div that's talking about the name of the person, right? So we have this identifier here. The property of this span of information is the friend of a friend model, and this is the name of the person. And then we have some more information about that person here. We have the link, and we have that it is a weblog, and this is actually just my website, but this sort of indicates that this person has this blog, right? And then you have a tag here, an RDF tag here that indicates that this person in the parent span knows, or this is someone they're socially familiar with, this person whose name is Seth Brown, and you can dump in there any if Seth Brown had his own homepage, I could put that in there, I'm just using his Twitter account here for a way of linking to Seth. And then we have the tag here for the friend of a friend model for an image. And so an image of the person. And the source of that image file is just like in HTML. We have a source tag and a path. And of course we have our accessibility in mind with an alt tag. Right? And all this belongs in the one person span tag. Right? And then we have this other vocabulary down here that indicates in the friend of a friend model that this person holds an account. It's an online account. You can see these are all inside this holds account tag. And we have the tag here that indicates account service home page. And here, this is my Twitter account, indicated right down here. So we have sort of the home link to Twitter, establishing that this is, a main part of the Twitter system, and then the friend of a friend account name that we're associating with for this whole identifier here is my Twitter account there. Right? And so when you view all this in the page, and the idea is not, this isn't a page that I'm using as, say, my contact page. I could do that, but I haven't done that here. I'm using it as a sort of a placeholder, so that if someone were looking through my data, they would have this as another version of my basic contact information. So it's sort of like having a business card that's marked up semantically, or we see a lot of these electronic-based contact cards, V cards that people will attach to their email addresses and things, or to their emails, and that's something that somebody can pull down and use right in their contact book, because it's marked up in a way that their contact book, their address book, can understand that information, and it can pull out their name, it can pull out their email, pull out their job title, etc. So this is something that I created. Actually, if I'll jump down here this is the Phomatic. It's the friend of a friend model. It's a really fun way to get started doing some of this, and this is how I created this page here. I'm pretty sure, if I remember correctly. But this is sort of you can read through all this and figure out what's going on here. But what you have is this form that was created by this developer. Again, we're talking about people contributing to the semantic web community, and really getting behind and helping other people to get on board with that. And we're, so we have this really fun way of maybe creating your first RDF marked up page. And you can see that what this does is it's going to create this friends of a friend person profile for you. So you can go in here and you can fill out your information, fill out these forms, put in some information about your work, about your school, and some people you may know. Right? So put your friend in there, and you can add more fields here. And now when you get that all filled out, it has this toggle on-off switch here that'll obfuscate your email. So you better just leave that on. It's more protection. That'll keep you from, once you put this up on your site, you'll keep spam bots from grabbing your email or your friends' email addresses. Then you just click Phome here, and what it'll do is it'll output the code here for you, and then it'll give you some tips about what you can do. And at the very least, what you'll want to do is you'll want to take that the code that generates here, and it will look like this, something along these lines. And then you want to name it FOAF, F-O-A-F .rdf. And what this does is it indicates to computers who are coming to your site that you have this semantically marked up data available, and that it's RDF data, right? So it's sort of like you have an index or a contact or something .html, right? And so that suffix allows the computers to know what kind of a file it is. And lastly here, you can check out this second link, Ubiquity RDFA Validator and Checker. If you click that link, it will bring you to this page where it talks about how to start using this validator. The idea behind this validator is just the same as validating your HTML or your CSS. You want to have your syntax correct, and you want to be marking things up in the most efficient way possible. And so this installation page will walk you through how to use this validator in different programs and in different web browsers. It says right here, in short, for the time being, the recommended way is to use Firefox. So that's what I did. It's I think it's probably in the works for being available in a lot of the main popular web browsers. But it tells you up here that it's having some trouble with Internet Explorer and Safari and etc. So if you want to try it out, just try it out in Firefox to start with, right? And so it tells you here how to get it going. And so what I did was I opened up Firefox and I followed a couple directions, and basically all you're doing is browsing that page and then making a bookmark for it, right? So what you're doing here is in other words, I took that. I should actually back up here real quick. So if you try this, if you're going about these methods here, and you use, let me see, where is it? If you use this form, this Phomatic form, if these are not browser friendly, so your browser won't bring up this page if you name it this phof.rdf. If you'll see here in mine, I took this exact same code and I renamed the file person.html. So if you have an HTML file with that RDF code in it, you'll be able to browse it through your web browser. If you just upload the RDF, like if I put my, I can browse this with that RDF, and it'll just say beginning at 404. I haven't seen this before actually, but anyway, the point is that it won't. What you want to do if you want to browse this is to just call it person.html, or call it whatever you want .html. Don't override any of your other files, because if you use this validator here, you'll see that I'm actually visiting the person.html page, right? And then so I bookmarked the RDFA validator, so I'll just click that, and it will run, and you'll see down here in the corner that Ubiquity Message Library loading is complete. So it ran the validator over my code, and then it will give you this bar down here, this dialog panel, and it will tell you what you have semantically marked up, right? And this is not, this is for developers who are, wanting to work with this and wanting to see, the validation working. This isn't something, that it's not going to really give you a ton of explanation if you have something wrong here. You're going to want to be able to recognize any errors in order to use this. So it's kind of just a backup way of going over, so in other words, what you want to see here is what you'd expect to see here. And it'll call out any other problems and bring those to your attention. All right, so that's the validator. And losing my mouse. All right, so those are feel free to visit this site anytime, and I'll leave these lessons up here. I'm gonna try to keep adding examples and tutorials and things about getting started and marking up your websites semantically. All right. So in order to get started, it's really, this stuff is a lot. There's a lot to it. It can get very complicated very fast. So what you want to do is just start slowly. Start thinking about it. Every time you make up a page, can you mark up any of that code semantically? And if so, you might start by looking at the RDF examples, because RDF is sort of the as we know now, the standard for semantic markup. And so if you think that there's something in there you could mark up semantically, look it up. Try it out. See what you can do to start gradually getting into this this new model, this new way, because it's not a whole lot different than what you've been doing. But it does take some mindfulness and some preparation and some reading and some studying up on it, and then like everything else that we do, just keep trying it out and look for validators and things that can help you to sort of get to the point where you're more and more comfortable with this with this newer technology. And the best place to start is the w3.org site. It's the W3C, the World Wide Web Consortium. And there are a lot of sources out there, a lot of resources, but I would encourage everyone to at least start with the W3C and read over the areas that they have that you're interested in pursuing, and just use that to your advantage. They also have a lot of tutorials in place, so those are actually very helpful as well. And last but not least, I'm learning all this stuff too as we go, and really excited about it. So if you have questions or something you want to talk about, just I'd be happy to chat with you about it. Do we have any questions or comments at this time? All right, again, if you have questions that come up and I can help, my Art Institute email address is gotoole@aii.edu. It's just gotoole@aii. I'll be happy to talk with you about it. Just to mention here, we have the AI open source user group that we're trying to get off the ground. So if you have any interest in open source programming, if you want to sort of start up a user group, I think that'd be really great. Let me know. You can find more information out about it from o'toole.info. And if that's all for now, thank you for your time. I hope you learned a little bit.